G'day guys and welcome back to my channel. So like I said in the last video, just because it took me all up over an hour of waiting for a bit of copper to etch, and then the Sharpie would come off and I'd have to take it out before the tracks started to get eaten away and re-Sharpie it after cleaning it up and put it back in, and the ammonium persulfate solution I had was no good. That was all. I've explained this in the last video. I've got video footage of the terrible, I don't know what you want to call it, process of trying to etch the board, but I'm just going to pause the video because I can just see a little copper line across the top there and there that I don't like, and a thin bit there. I'm just going to go and Dremel that off. I'll be back in a sec. Alright, so I've just gone and cleaned that up a little bit more, made a couple of other areas look a little bit prettier. First thing I'm going to do is going to come in and flood everything with a small layer of solder, tin everything. Now we don't want it thick just yet, you'll see why in a second. Alright. I'm happy with that. I think the first device I'm going to solder in is going to be this. I'm guessing these pins, this was harvested out of a circuit board, so I'm just tinning these pins up because they're probably covered in lead-free solder. For those that are wondering, I basically only use lead-free solder. I mean leaded solder, sorry. And let me just have a look at my solder paste. I can't remember what solder paste I got. I think that might be lead-free. No, even my solder paste is leaded. Yeah, I just hate lead-free crap. I do not like working with it. Never have and probably never will. And I know I'm not the only one. So let's tack everything down first quickly. Okay, now that's all tacked down, I can come in and just touch up these pins with a bit more solder. Alright, I'm going to thicken this ground trace up. It's always good to have a nice thick ground trace, just for those of you that are getting into doing this sort of stuff, because the ground trace is usually where you're trying to shunt all your noise to. Whether it's with capacitors or what it's with, you're usually using the ground trace. I'm just making a couple of the tracks a little bit wider. Sorry, not wider, thicker. But so you don't, my point I'm getting at is you don't want resistance in your ground trace. That is not a good thing. Not much space. The way I mounted it, it didn't end up. Oh, not good. That's alright. I can resolder that down straight. Oh, that's right, I hadn't filled that in yet. Right, okay, that was just tacked on. I was wondering why that popped off so easy. Want that about there. Yeah. I want that. About there. Sorry if my head's been getting in the way. Yeah, it has. Okay, sorry. Let's just move all this over here and give you guys a bit of a better view. Okay, so I'm just trying to fit my diode in the back there. I'll just finish soldering these pins that hold the heatsink down. These don't serve any electrical purpose, they're just there for mechanical support. That pin there and that pin there. Alright, we'll put the anti-parallel diode in. Actually, just give me 1 sec. Alright, sorry about that. Where was I? The diode. Alright, so I'm gonna get my helping hand over here. I realise you can't see it. It's just here. You can just see, yeah. That's what I'm talking about when I talk about my helping hand. You can't see. Oh, it's barely in shot there. There you go. Now I can maybe if I just bring my camera back a little bit too. Yeah, that's better for you guys. Now when I solder something on the helping hand, you can see that too. So again, I'm just sort of tinning the legs up very quickly so that I can tack it on here. Probably going to have to use a pair of tweezers. I might actually use the helping hand here to hold the board for me, like so. And then I can come in with my diode on the tweezers. Just like that. Alright, now just, oh, that's got plenty of clearance from the heatsink, beautiful. Alright, I'll just flow that diode in properly with a bit more solder. That's looking good. I'm just going to thicken up the traces that go to the diode. I forgot to do that. I realise it's not really necessary, but as I've said in a few of my videos, I'm just one of those people that likes everything to be as good as it can be. Okay, I wasn't happy with that center leg on the regulator, so I just resoldered that down. Actually, that left pin I'm not too happy with. I just want to make sure it's solid because I'm making my meter battery powered. There's a chance it will get moved around, possibly even go in a vehicle and go somewhere. I don't want things to vibrate and come off. This is why I use leaded solder, because I mean, I'll tell you something, and people out there who solder will have soldered for years and actually know how to solder properly and work with leaded solder will be able to tell you that I'm not bullshitting you here, but you know, like, yes, it's good to J-hook stuff together and, you know, go through the board holes instead of just putting it on top like what I'm doing. That does add extra strength, but if you use proper leaded solder, like good quality leaded solder with good quality flux, and all your solder's done properly, it's nice and shiny like that, and it flows properly, it doesn't ever break. I'm telling you now. You know, I've got stuff that I soldered when I was a kid, when I first basically learnt how to solder, and the soldering is still perfectly fine, and it's been literally thrown out the window and all sorts. You don't even want to know. And all that stuff is fine. I can't say the same for things that were made with lead-free solder. Not that I made things with lead-free solder, but certainly owned things that were made with lead-free solder, and I can tell you now, I've had plenty of problems with all of those devices. Many things like power supplies and stereo systems and just random electronics. But yeah, that lead-free solder, I don't like it. I will happily work with leaded solder any day. Let's try and move this a little bit more that way. I don't want that to touch the heat sink, so I'm just going to move it in that direction. And just give it a little bit of a bend like that. Same with that one. I just don't want those capacitors touching the heat sink, even though, like I said, this thing barely gets to 40, 45 degrees maybe. I'd say about 40 degrees. I still don't want the capacitors close to it, you know. That's actually a point to talk about for people who are learning electronics here too. The reason why the bulk capacitors are going on the inside and the MKTs are going on the outside, these are the ones that we're using to try and filter out high frequency content. Now the high frequency content is going to be coming in from the boost regulator. That's the point where it's going to be coming in, so we're going to want this as close to that as possible. And on the output, not just to filter what does pass through to the output, but anything from the switching regulators in the meter itself that causes noise to come back down the power wires, that will be filtering that too. So that's why we design boards in this manner. It depends on the board you're making and the requirements of it as to exactly how you will do that, how you would decide where your components go. For example, if you're working with an op-amp or a microcontroller, sometimes you might want to put what's known as the bypass capacitor, usually like a 1 microfarad or 100 nanofarad capacitor. You might want to mount that right across the actual regulator or the op-amp or whatever it is you're using, right? In some cases, doing that actually might cause a problem. If I was to sit here and try and explain all of this right now, it would just turn into another video, but circuit layout and capacitor placement is actually very important. You can't just put stuff where it looks good, if that makes sense. You can't just go, I like the look of this here, so I'm going to put it here. You have to do it because it, electrically speaking, will work. So that's that board finished. That's my little linear regulator. We'll just bend them up to make it look straight and pretty. There we go. That's my little 5 volt linear regulator. So, before I end this video, because like I said, this is going to be the build video. Actually, we'll do a couple of other things probably before I end the video too. Why not? Maybe we'll start joining the USB interface board up to the meter and run some power wires out too before we end the video. And then the next video I'll do the actual assembly on it. Well, that wire doesn't want to take solder at all. Come on. Let's just give it a quick test. When I say give it a test, I mean I want to see the ripple and noise on it under load. Now it's all soldered on a nice board, eliminating all the connection resistance. I want to see how it performs. It's either going to be the same as before or it could be slightly better. So let's have a quick look. Alright. Alright, my scope's actually quieter at idle now. I'm not making this up. I'll show you guys. I'm pretty sure the other day it was around 200 microvolts at standby current. I'm quite happy with that. At standby current, we've got 640 to 660 microvolts peak to peak and 60.85 microvolts RMS. Okay. With it switched on. Wow, guys. Wow. Wow. You know how I was saying to you guys in the last video, when everything's soldered on the board, it's going to perform way better noise-wise than on the breadboard. Before we had 9 to 10 millivolts peak to peak of noise and ripple, and I think it was 1 point something millivolts peak to peak. No, 900 microvolts peak to peak. You guys have got to have a look at this. 2 millivolts peak to peak. 300 microvolts RMS. And that's at 500 microvolts of division. See? So you can look at the waveform and count the divisions if you're not sure. But 1, 2, 3, 4, 2 millivolts peak to peak. And no, there's no ripple coming through my power supply because it's quiet. And don't forget, this will be running off a battery, so that's why I'm not focusing on that area. We're just looking at the switching noise coming from the switching converter. Absolutely beautiful. I could not be more happy. Two millivolts peak to peak, 300 microvolts RMS. Remember what the supply that was in here was? Does anyone remember? It was 1 or 2.56 millivolts RMS, and the peak to peak was 50 millivolts. And it looked terrible too. It was not a nice, even, smooth waveform like that. Because that's the other thing about noise too. It's not just how much current is behind the noise and how much voltage is behind the noise, but the type of noise can have a massive effect. If it's almost like a white noise and very consistent, it might not have much effect. If it's got a lot of sharp spikes and then nothing for a bit, and sharp spikes and rings and stuff in it, like say a flyback converter running in discontinuous mode, that can cause more problems with sensitive equipment that's running off of it. So yeah, I'm very pleased with this. I'm pleased with the type of noise that I'm seeing, and I'm pleased with the noise values. I'm more than pleased. So that's just wonderful. That's just truly wonderful. I'm sure everybody wants to see this run off the battery just quickly. Why not? I mean, it's kind of the whole point of the video, isn't it? We want to convert the multimeter to run off of a battery. We know it works anyway. But just for proof, just for people who are learning electronics and don't understand how we know that this is going to work 100% already, I'll just show you that it does. And there you go. One battery powered multimeter. So now I've still got to work out what to do about the USB port situation, because I forget what standard that's called, but it's not the, I want USB-C. So I guess I've got to take a trip to JCar. I've got to see if they've got nice fresh ammonium persulfate, because the stuff they've been selling me has been sort of like lumpy and not so fresh, some of the jars, and I've copped it a couple of times and I've noticed, I don't know, I think they're getting the same old batch from their warehouse. I don't know what it is, but when I go buy a fresh jar, it just doesn't, it still seems to be taking too long to etch the boards, and then after I've had the jar for even a month or two, it's like just completely all clumped up. So and that's with me like leaving in the little bag, the satchel bag that comes in, and squeezing all the air out of it and all that. So I don't know, but yeah, you'll see what I mean if I upload that other video with the terrible, I might title it World's Worst PCB Etch or something like that. But there is our battery powered multimeter. There is the battery. There's the boost converter. That's the linear regulator. And there's the charger that now charges the battery at 500 milliamps, not an amp. We swapped that resistor in another video to 2.4K. That's right, 1.2 tells the TP4056 to charge at 1 amp. 2.4K tells it to charge at half an amp. So that's what I set it at. And this runs completely just, it's like the same temperature as me. I'd say it's about 40 degrees Celsius. Probably no more. And yes, I've let it run for a while. I've also worked out that the resistance mode's the mode that takes the most power, and let it run like that, and yeah. Alright. Let's move on. Actually, when I go to JCar, I'll see if there's any bigger batteries that they sell there. I had a huge 10,000 milliamp pack somewhere and I can't find it. A LiPo pack like this. I don't know where it's gone. Also, I just need to do some research because I'm a bit of a dumb shit like this. I'm not up to date on my lithium ion BMS module technology. I understand the battery chemistry really well and all that sort of stuff. Extremely well, actually. I could give you guys a lecture on lithium ion batteries if anyone is interested in learning about them. lithium ions and lithium ion phosphates and other battery types like nickel cadmium, which is an older technology. We use nickel metal hydride now. I could talk about battery chemistries and how to take care of your batteries and get more out of them, and how to abuse them, and why they degrade and why they don't degrade under other conditions and all that sort of stuff. But anyway, I digress. When I go to JCar, which I think I'm going to go there tomorrow just to see, I'll just grab that USB-C breakout board and I'll see if they've got any bigger LiPo packs. Hopefully they do. And I'll grab one. So, oh, that is Phillips head. Let's take all this stuff apart and get it ready for mounting. I've still got some work to do on this boost board, so I guess I'm going to have to do that. And you know what, we'll do that now. We'll do that. That's what we'll do now. I want to remove that panel meter. So that worked out nicely, guys. I was going to build one of these, and I'm seriously wishing I did now. Honestly, I'm not kidding you. I mean, like, there's all these extra parts on here, and a panel meter, and a micro to control, and a voltage regulator for that, and I'm just like, man, I could have just grabbed an LM2577, a few capacitors, a few resistors, an inductor, a diode, built a couple of RC snubbers around things, and made a supply that was quieter than this in the same size board. Oh well. I saw this when I was in JCar and I was like, this is too cheap. It's like, I should just get it. I don't know how easy this panel meter is going to come out. I'm going to try and just flood it with leaded solder and then get the desoldering gun on it. And just again, for anyone that missed out, the reason why I want the panel meter gone is because this is running off batteries. So the voltmeter IC, the panel meter, the voltage regulator that provides voltage for that circuitry, I want all of that gone so that it's just the boost converter running. I don't want any power being wasted at all. It looks to me no, there's actually more than what you think going on under here. And I can't see what I say is what, like what's for the boost converter itself and what's just for the voltage. The panel meter. I guess there's only one way to find out, right? That's good. The other thing I want to do is hook this charging module up to the battery. There's two LEDs on here. I've noticed one just comes on, when you are charging the battery. I'm assuming the other one comes on when it's charged. But I want to work out whichever LED it is that comes on when it's charged. I want to bring that also to the front of the case. Actually, I'm going to put it right in that top corner because I can literally put a hole perfectly there. And I'll show you exactly the LED I'm thinking of. I got boxes of LEDs, I got boxes of new LEDs, boxes of old LEDs, but nice little watery blue, smoky blue colour LED, just because that'll look different. And I just want that to sort of poke out behind this corner. It's just going to go in there. There you go, now you can see it. So it's going to go down in there and poke out the front. And that's going to be the battery charged indicator. So I know that I can unplug it if I don't want it referenced to mains anymore. Or just drawing power. Yeah, I'll take that off too. I'm going to steal a couple parts off a few for myself. Just to chuck in my drawer. Because why not? I paid like $10 or some shit. Maybe like $20, I can't remember. Not too much for this little board, but I mean, I don't need all this stuff. Even these LEDs, like I don't want LEDs just lit up in the back, taking my battery power. Man, surface mount is getting small. Well, there's a resistor here from... Oh, that's the 1.2k resistor that I changed to a 2.4. Tell you what, surface mount parts are just so small these days, it just blows my mind. I mean, to be honest, you've been able to get fairly small surface mount parts for some time. It's not like it just happened, but... How do I say this? The, what do you call it? The chance of you finding really small surface mount parts on something that you're working on these days is ridiculously large. And I don't like that. Just get rid of some flux. Alright. That's the in and the out indication LED that shows if you're looking at the in voltage or the out voltage. This is ready. Oh yeah, this is actually going to work perfectly for this. I should get a small nozzle, but did I just knock my heatsink off? Yeah, I just knocked the heatsink off. I got to replaster that again. You know what? That's actually the exact same plaster that was on it. I guess I did get this from J-Car. I guess it's probably pretty standard stuff, the heatsink plaster glue. I haven't used it before. I don't really, most of the heatsinks I've mounted on top of micros and I had like a self-adhesive sticky sort of stuff on them. And all the rest is just normal heatsink compounds when I'm screwing something to a heatsink, so. Sounds like This is getting a bit blocked. Yeah, I know what it is. It's the filter in. Must be getting full. Oh, I need to give that a clean out. Damn, I really need to give that a clean out. I was looking at it and I was thinking, oh, it's alright, I'll continue on this. That's a clump. I do have heaps of these little sponges, so I could replace if I want to. But I found that you can just sort of manglate the sponge around a little bit and get good airflow. Gets good airflow through it again, quite a few times before you have to actually replace the thing. Which saves me going online and trying to find the replacements. I get I could just cut it out of a bigger piece, but this does the trick. And I know it does the trick and doesn't get the rest of my pump dirty or anything like that. You know how I know why? There's a second filter in the back here, and as you can see, it's clean. So if what I was doing was not good and dirt was getting into the pump, you'd see, because the second filter, which is the exact same material, would catch it. So don't worry. I think I'll just soldering iron's gone to sleep. That's right. I'll continue on the other pins. Pretty much got it all, so that's good. It's basically ready to come out. I had a feeling this was getting a bit blocked up. I can feel it. Alright. That's better. I've got to be careful because there are ICs under here, and I'm pretty sure that they're both just for the panel meter, but one could be something to do with the PWM drive circuitry for the I'm going silly now, the switcher, the little boost converter. A couple of these holes, just a couple, didn't want to come out, so I'm just going to reflood them with leaded solder again. Yeah, it's just 4 holes. Give us 1 minute, I'll be back in a sec. Alright. Come on. I'm just not having luck with this one pin. Nah, that's blocked. I freaking knew it was blocking up. No. Got bad news, guys. Unless this filter is actually blocked up, but not with solder, but with like flux or something. No way, it was. Look at that, the filter I was literally just saying 2 minutes ago, it's all good, I don't need to replace it. So that's interesting. I didn't know that. So there you go, the first filter catches all the dirty stuff and the second one sort of looks like a cigarette butt. That's okay. Well, we'll replace that quickly. A couple of random bits in there. And then I've got a couple of replacement tubes because I heard that the plastic is from the heat can crack and then you lose your vacuum, so I bought a pack of them. So I'm all stocked up. I've got all other parts too, the heaters and everything. I made sure I stocked up when I bought the thing. I got all the extras, all the spare parts. And this is actually in like 2 years or so the first time I've had to change that second filter. And today's the first day I've heard it change tone. I'm used to the sound this thing makes, so I can tell if it's blocked or not. See the difference there? Well, I'll just quickly put some solder in there again so it's got something to start sucking, because after that last go, not having suction on it, it wouldn't have really pulled the solder out the hole. Now I've got solder everywhere. Alright. Goodness, after all this, my tip's dirty now. Alright. Much better. almost looks like it can break out. I think that can come out. I'm just going to have to be patient and work at it. Yeah, it's coming. Not again. Every time I go to pick my soldering iron up, it's gone to sleep. Got that side out. Yeah, there we go. All right. Oh, there's actually 3 chips under here. Wow. All that just for a little boost converter? I'm just curious, as maybe some of you might be, so let's have a look. Is this just the output diode? Yeah, that looks like the output diode. Yeah, that's the output diode. Okay. That's the switching FET. I would imagine that that little chip's the controller, but if so, then why in God's name is there 3 chips here just for a voltmeter? One's a EEPROM AT24CO2, so it's a 2 kilobyte, or was it 2 byte flash IC? I can't read the numbers on the rest. That's a 7133 regulator. That is a transistor by the looks of things, with 3 small transistors underneath it. Sorry. What looks like a Schottky diode, 2 transistors and a MOSFET. Oh, what? Is this how they're driving the screen? There's a 74HC595, an AT24CO2 flash RAM, and this chip in the middle, it's got its numbers sanded off it. I can tell you now that none of that's the switching circuitry, so that's good. But are there any like enable pins that go to that IC there? You know, I'm just going to check. Where's the gate? The gate's driven by a transistor, okay. Yeah, and it's controlled by that chip, right. The thing that's interesting to me is that I think that's the output voltage divider for the panel meter to read the output voltage, but the input seems like there's a couple of pins coming off this chip going down into these components and the rest of it goes that way. My question is, if I remove everything off there, will my boost converter stop working? Can I just leave that there? Because, you know, anything that's drawing current, I don't want it on there, period. Let's take off what we know is not anything to do with the boost converter for now. Alright. Okay, there's a number written on the board underneath that chip, 1711A. Maybe it's on the bottom of it. No, on the bottom of it it says 240202G. That's kind of meaningless. Well, anyway. Those are the 3 chips how they came off the board. Let's just see what it's doing currently, just so we know that this IC doesn't have some sort of power good signal or something provided back from this circuitry that we have to provide ourselves. I just want to make sure it's still running basically. Should be at this point. Yeah, 7.96. Alright. So let's just see if the 7133 regulator is powering anything else on here. Okay, no, it's not. The only thing that I don't know what's going on, if it's just the measuring the voltage from the chips, the chip for some reason instead of sensing it straight from where it comes in. I don't know. I don't know what's up with that. Okay, there's only 2 traces that go down there actually. One of them's coming off the other side of a capacitor that goes to ground, and that other side of the capacitor goes back to the chip too. And the other's coming off another pin off the chip via a 1 kilo ohm resistor. Unless that 1K needs to get pulled down to ground, I can't see anything else on here that's going to prevent that chip from starting up. So let's just go happy lucky with it and just take all this stuff off. Hope I'm right, eh? Otherwise we'll be putting everything back on. Tell you what, I'll take this big transistor off first, because I have no idea what it's actually there for. And we'll just see if the thing still powers up without that on there, because that'll give us some indication if that circuitry that's running down there has got anything to do with the boost regulator. Hey. Really? That transistor's part of it. Wow. Really? Yeah. Okay. So it looks as if what's still on the board is going to be kept. Look, that's alright, I'm happy with that anyway. I got the 7133 off and the 3 chips underneath the panel meter plus the panel meter plus the 2 LEDs. That's all the stuff really I'd say that was drawing the extra current anyway. So I'm kind of happy now. Might just add some more of my own solder to that. It's very hard to get the solder to be up under the pins, I tell you, with a soldering iron. God, I keep touching the solder on my iron. I'm trying to heat the pin up and force the solder into the pin. Oh, that's good. Okay, so that. Alright. So let's just verify that that works without the 7133 on there. I'm pretty sure it does. I think I already did this, I can't remember. Sorry guys. Mate, really? It doesn't work without the 7133 either. I wasn't expecting that. I really wasn't expecting that. I'm just going to use my soldering iron and my slide it on trick. Come on, quick, while the board's still on. Alright, so I'm sure it was working at this point. Well, I have got the board really hot. I hope it's not just in thermal protect. I didn't think about that. Man, oh well. Okay, look, that's working again, 8 volts. Look, the 7133 is a linear regulator, so if it's only powering that, and that's removed, there's no current passing through it anyway, so it's not taking any power. So look, honestly, that's good enough. All the crap on there that was taking power is gone now. We don't have to worry about that. So let's put this heatsink back on. What's the deal with thermal plaster? Why on earth does it go off so quick? I only opened this yesterday. And it was all like blocked up inside. I don't understand. Back to the same problem again today. I'll have to get more of that too. Oh, this is ridiculous. I can't even get it out. Guess where I got it from? Sure, you can guess. Same place I get everything else that doesn't work. J-Car. Mate, come on. Yeah, finally. Hello. I'll take that. I don't know what the go is with this, but it just goes off. It doesn't seem to matter which way I put it around in the stand. Alright. I just want to make sure there's no clumpy bits in there. What am I going to use? Use this one. He smells like plaster. What the hell? It's got a plaster smell to it. I know it's called plaster. I just think that's funny because it's sort of like silicone when you look at it. Just wipe my oils off that. I'm just going to go and roughen this up over some wet and dry sandpaper. I didn't go crazy on it, but all those little scratches will give that paste something to bite onto and make a secure bond. What do you say we rush it? The drying process. Well, heat just makes it really runny. Wonder if it dries as it cools down. That we're going to find out now. I think I might leave that video. I think I might leave this video off where it is for now because, well, I've taken all the stuff that I wanted to take off the boost regulator. I've built the linear regulator. We've modified the charge current on this. We've got our battery ready. We've actually run it off the battery and seen the meter work. So, oh, you know what? We're going to make up a wiring loom for the meter. We'll do that now too. That way, when I come in tomorrow, everything's just modular and we can just start assembling it. I'm just going to go put these little parts away. I'll pause the video so you don't get bored. Alright, I've put those components away. I'm just going to go and drill a small hole here that's going to very tightly fit this with maybe some cyanoacrylate or something. I'll be back in a moment. Alright, so that's that done. That fits in there perfectly like so. It's going to get put in from the back. So it'll just look like that. Almost like it was already there. So I guess in preparation we'll solder and heat shrink some wires to that. I mean, it's all stuff that I got to do before we can just go and install. So we might as well do it now, right? Can't put it together without doing all this stuff first. Now that LED, because of where I'm going to be soldering it to on the board, I'm soldering it to a really crappy spot. It's not a crappy spot, I mean it's replacing a surface mount LED, so there's not a lot of pad to solder to. It's plenty enough to solder to, but choose small wire, because if you choose big wire and solder it to a small pad, just the weight of the wire will cause that much tension on the pad, it will rip it off. You don't want to do that, do you? Yeah, how much am I going to need? I'll just leave this whole length on there, and I'll just I'll actually just cut it to length when we go to install it, when we build the thing. Here's the helping hand again, seeing as... Oh, it is in view. Cool. Seeing as it's now in view. Makes it easier for me, and you guys can still see. Pretty mediocre solder joints, but it'll do for what it is. Alright, that's our front panel LED. Alright, I'm just going to go get some super glue. earth is leaking on my table? What? Makes no sense. It's like there's some sort of epoxy or something leaking. Got a few different glues up there, so that's a bit of a worry. I know something's leaking. Ah. That wasn't intended. Okay, got that where I want it. I'm just going to put in a little drop. Just make sure that's actually gone down in there. One more drop down. Oh. Yep, there we go. Perfect. Okay, so that's that. Spilt a little bit on the side. Okay, we now have one glued in LED. Leaking glue out the front. We don't want that. And you know what the beauty of having a boost converter in here with adjustable voltages on it? In the future, whatever battery topology I choose to use, the boost converter is just going to step it up to the voltage I need for the 5-volt regulator, so I can change the battery. All I got to do is change the charging module and the battery, you know? That's pretty cool. Most devices, it's not like you can just put different voltage batteries in them. So there we go. That's the LED. Now, 3 of these wires have just got to be spliced together. However, the other 2 need to be spliced together but then teed off so that we can actually give this thing power. So for that, I'm going to use a couple of pieces of wire. just going to hook all this up in parallel to the power wires. That's actually quite a considerably thin gauge wire that I just got. I'm really not happy with the thickness of that. Again, from J-Car. They do sell thicker wire. I'm not saying that they only sell thin wire. I'm just saying that the next wire they sell is 18 gauge, and that's a little bit overkill for this, but whatever. Alright. Where'd my drink go? I had a drink in here and I've lost it. Alright. Whatever. Alright, how much copper's in these ones? Oh yeah? Much better. Just a little bit more than what's in the original. Alright. We'll slide some heat shrink over the power wires. Sorry, I was just having a look on my phone because I've got an important phone call coming. And I don't want to miss it whilst I'm recording on my phone. Oh, you know what? I'm going to go over the top. Does that heat shrink fit? No, that's alright. I've got bigger heat shrink. So that's what I'm going to do. The other wires will do the other way, like I spliced the e-bike harness together. But this I'll just do this way. The main thing is that it's nice and soldered. Not the best twist. I could have cut those wires a bit longer. Alright, that's better. I've just grabbed some heat shrink. So that's that. Now for our USB interface. Now you see why I tried to make the marks just a little bit back from the end of the wire. That way I can still count them. 1, 2, 3, 1, 2, 1. So if I marked up to the end of the wire where I was going to strip, I wouldn't have been able to count my marks afterwards. Now I know this might seem like just a trivial, stupid thing to point out, but trust me, forget that. Do it up at the end, then strip your wires, and then find that you've got odd numbers of marks or marks that don't make sense, and I can tell you now that can be a bit of a headache. Alright. I can stop dropping my heat shrink on the floor. We'll just get this done. I'm not gonna lie, I'm sort of getting bored. I want to just pack it in for the night. It's getting late. Got a bit of cleaning to do. I always have cleaning to do because I live in a house full of cats and my missus isn't here at the moment, so it's just me. Usually it's the both of us. So when it's just me, it's even more work on me, and let's just say I'm not coping. I'm trying my hardest to get videos done in my spare time every day, but it's just hard, honestly. Especially without someone here to help you out at the moment. Hopefully everything goes good with our lawyers and that, and she can move back in. Truth be told, I should have stripped these wires a little bit longer and twisted them together and then slid the heat shrink over it, but that's thick enough that I'll be able to fold it over after I solder it and still get the heat shrink over it, so it's alright. What I mean by that is like that. Oh, I still got that piece of heat shrink on there. That's hilarious. That's funny as. Alright. We only need these 3 pieces for the USB lines. Let's just double check that we've got 3 to 3, 2 to 2, and 1 to 1. Yep. Cool. It's always better to double check your stuff. I know the older you get, the longer you've been doing it, the more annoying it gets. You're like, come on, I don't need to. Just keep doing it, because I'm telling you, every time I don't double check something, I power it on, it goes bang. Now, oddly enough, every time I do check something, there's never anything wrong, but it's always that time that you don't check it, it'll blow up in your face. So just check your work. It doesn't matter how experienced you are, everyone makes mistakes. And sometimes you just plain forget something. It's not even that you make a mistake, you know. Your brain might be elsewhere due to stress or whatever it may be. Just double check your work, guys. I'm happy with them. I'll just tip the excess solder out of here, wire strippings out. So there we go. We're ready for assembly now. Well, actually, one other thing that I had to do was I want to work out where I'm going to mount everything. So this board, I'm thinking I'm just going to mount it basically there. And you know what? That almost clears just as it is. If I just cut a couple of slots into there, it'll sort of give the board somewhere to sit. Yeah, look at that. You can't ask for more. It actually clears the case now. Wow. That's nice. Okay. The reason I want that there is because what I was thinking is the heat sink can literally just sit there behind where the old IEC socket went. And I think that's cool. So I'm going to do that. So that'll get mounted there. The battery, I don't know yet. I haven't thought about that. The charge module, I think I might wait until I get the USB-C breakout board, because I'm probably going to put them right next to each other. The boost module, can we fit it? Where can we fit it? Okay, so I'm just not clearing on the boost module. It's like a capacitor or maybe a relay. Probably a relay. Anyways, yeah, I'd say it's a relay. Anyways, let's go further over here. How about now? No, that's just in the way. Okay. Yeah, that's a relay. Crap, you know what I just remembered? This heatsink's still drying. It's still like completely paste. It takes so long to set that stuff. Sorry guys. I think the only thing I can do, you know what? The boost converter runs completely cold. I'm going to mount the boost converter on the back of the screen. Although I was thinking I might have to put the battery there, so I just don't want the boost converter spewing off noise over into that circuit board. Okay, there's a lot of plastic standoffs in here that I can Dremel out to clear more space. I think that's what I'm going to do. I'll leave this video for now. I'll Dremel out a few bits of plastic in my own time, and I'll work out how I'm going to make this all fit so I don't bore you guys just watching me literally just stare at plastic and shave little bits off here and there and whatnot. But yeah, we are ready to build basically. We have our linear regulator, our battery, our boost module, everything's ready to go. So come back tomorrow and watch me build it. Alright guys, take care. I'll see you in the next video.